One other thing that I think is super important, because I say, well, kind of what are the rate limiters? It's the compute, it's the network, and it's the power.
Yep.
Copper's has its place, but over distances and stuff, it becomes very power inefficient. And by the way, GPUs can be very power inefficient. For certain use cases, they can be great. We're seeing exponential scales in some way, but there is also a reason that many companies want to design their own. They have a very specific workload in mind, or several workloads. They can build their own software. They can do these things. How is Marvell sort of thinking about addressing that? Because that seems like one of the biggest opportunities is sort of addressing the power problem. And while China might be happy to build coal-fired plants 2 a week or whatever they're building, in the U.S., we're trying to build nuclear, but that's like a decade out, Chris. It's not going to happen that quickly.
Yeah, ultimately, that's what we wake up and think about every single day. When you're building silicon, you tend to think about power, performance, and area is cost. So it's like, how much is it going to cost? What's the performance of it, and how much power? And to the point you made earlier in terms of capital allocation, cost is almost not the discussion anymore. It's how much performance at what power is really all of the discussion that you can have right now. And ultimately, everything we're doing is focused on that. You mentioned custom earlier. That's exactly why custom. By the way, why are we doing AI work on GPUs instead of CPUs in the first place? Because they're more specialized to do this type of work. So if you can make a more specialized XPU or AI processor for a more specialized workload, it's going to be more power efficient, right? And same thing, if you're addressing any possible application, you're going to build one type of a platform that sort of can deal with anything. But if you're saying, no, I'm going to focus on this model or this application, you can build not only an optimized XPU, but an optimized platform that connects those together and optimizes the connections between XPUs and the connections to memory and the ratios of all of those for the way your model is split and spread logically across that logical XPU. And so all of that has power and space in mind. Cost is obviously an important one, but even more important is, hey, this is the space and power envelope that I have. What's the most optimal way to deploy infrastructure to attack my problem?